In the last class, we have been discussing about the requirements of modulation. Today we are going to discuss what are the different types of modulation. Last class we have been telling about the signal which is a low frequency wave and a carrier wave which is of a higher frequency. This is the signal which is of low frequency and this is the carrier wave which is of a higher frequency. So now for sending the signal through for a long distance, we have to modulate this carrier wave according to the parameters of the signal. So if you look at a wave, the parameters that can be modified are its amplitude, frequency and phase. Amplitude, frequency and phase. So these three parameters, ഒരു വേവ് എടുത്തു കഴിഞ്ഞാൽ അതിന്റെ ക്യാരക്ടറിസ്റ്റിക് ആണ്, അതിനൊരു ആംപ്ലിറ്റ്യൂഡ് ഉണ്ട്, ഒരു ഫ്രീക്വൻസി ഉണ്ട്. This is the amplitude. You can see how many cycles per second, that is the frequency. Then phase of the wave is there. ഈ മൂന്ന് പാരാമീറ്റേഴ്സ് ആണ് നമുക്ക് നമ്മുടെ സിഗ്നൽ അനുസരിച്ചിട്ട് കാരിയറിൽ മാറ്റങ്ങൾ വരുത്തുന്നത്. So the modification of the carrier wave should be done according to, അപ്പോൾ ഈ സിഗ്നലിന്റെ ആംപ്ലിറ്റ്യൂഡിന്റെ വേരിയേഷൻ അനുസരിച്ചിട്ട് നമുക്ക് ഇതിലെ പാരാമീറ്റേഴ്സ് ഏതാണോ മാറ്റുന്നത് അതിനനുസരിച്ചിട്ടാണ് നമുക്ക് ഏത് ടൈപ്പ് ഓഫ് മോഡുലേഷൻ ആണെന്ന് പറയുന്നത്. ഇപ്പൊ carrier വേവിന്റെ ആംപ്ലിറ്റ്യൂഡ് ആണ് നമ്മുടെ സിഗ്നൽ അനുസരിച്ച് മാറുന്നതെന്നുണ്ടെങ്കിൽ നമുക്ക് കിട്ടുന്നത് ആംപ്ലിറ്റ്യൂഡ് മോഡുലേറ്റഡ് വേവ് ആണ്. That means if you are modifying the amplitude of the carrier wave according to that of our signal, we get amplitude modulated wave. If we are going to change the frequency of this carrier signal according to the amplitude of this, frequency of the carrier according to the signal, then it will be frequency modulation. In the frequency can be frequency modulation. Right now we are going to discuss about, first we are going to discuss about amplitude modulation. So let us discuss about amplitude modulation. This is our signal. This is our carrier wave of high frequency. Now, this is our signal ആണ്, ഇത് carrier wave ആണ്. Now, when you modulate this carrier wave with the signal using the amplitude modulation, that means amplitude of the carrier wave is going to change according to the signal. Signal അനുസരിച്ചിട്ട് carrier wave ന്റെ amplitude മാറുന്നതാണ്. So what happens is the modulated wave will look like this. See, what happens is the amplitude of the carrier wave is getting modified according to our signal. നമ്മുടെ സിഗ്നലിന്റെ വേരിയേഷൻ അനുസരിച്ചിട്ട് carrier waveന്റെ amplitude മാറുകയാണ്. So you can see that the carrier wave is carrying our signal as an envelope. Over the carrier wave, the signal is placed and this can take the signal to a large distance. അപ്പോൾ ഇതാണ് ആംപ്ലിറ്റ്യൂഡ് മോഡുലേഷൻ സംഭവിക്കുന്നത്. ഈ വേരിയേഷൻസ് ഇവിടെ ഇൻകോർപ്പറേറ്റ് ചെയ്ത് വന്നിട്ടുണ്ട്. Let us say that instantaneous voltage here is ES. ഇലക്ട്രിക്കൽ എനർജിയാണ് നമ്മൾ ട്രാൻസ്മിറ്റ് ചെയ്യുന്നത്. S represents signal. This is EC. And this is the modulated wave. നമ്മൾ E എന്ന് റെപ്രസെന്റ് ചെയ്യാം. ഇവിടുത്തെ വോൾട്ടേജിനെ എനർജിയാണ് ക്യാരി ചെയ്യുന്നത്, വോൾട്ടേജ് ആയിട്ടാണ് ക്യാരി ചെയ്യുന്നത്. So this is the amplitude modulate. Here this is the modulated wave, which is the amplitude modulated. ഇപ്പോൾ amplitude modulated wave ആണത്. Okay. Now, how much the carrier wave is being modulated by the signal? എത്രമാത്രം ഇതിനെ മോഡുലേറ്റ് ചെയ്യപ്പെടുന്നു? മോഡുലേറ്റ് ചെയ്യാന്ന് വെച്ചാൽ അതിന്റെ ചേഞ്ച് ചെയ്യാണ്. How many times it is getting changed? What is the factor by which it is getting changed? അതാണ് നമ്മൾ മോഡുലേഷൻ ഫാക്ടർ എന്ന് പറയുന്നത്. Modulation factor, it is denoted by the symbol M. എന്താണ് മോഡുലേഷൻ ഫാക്ടർ? നമ്മുടെ കരിയർ വേവിനെ എത്രമാത്രം ചേഞ്ച് ചെയ്യുന്നു, ഹൗ മച്ച് ചേഞ്ച് ഇസ് കമ്മിങ് ഇൻ, ദാറ്റ് ഡിവൈഡഡ് ബൈ എന്തായിരിക്കും? ഹൗ മച്ച് ചേഞ്ചസ് നമുക്ക് അറിയേണ്ടത്, ഹൗ മച്ച് വാട്ട് ഇസ് ദ ഫാക്ടർ ബൈ വിച്ച് ഇറ്റ് ഇസ് ചേഞ്ചിങ് എന്നാണ് അറിയേണ്ടത്. അപ്പൊ എത്രയാണോ ആ ചേഞ്ച് സംഭവിച്ചത്, ദാറ്റ് ഡിവൈഡഡ് ബൈ ദ നോർമൽ ആംപ്ലിറ്റ്യൂഡ് ഓഫ് ദി കരിയർ വേവ്. ഓക്കെ, നമുക്കത് ഒന്ന് എഴുതാം. ചേഞ്ച് ദാറ്റ് ഈസ് ഈക്വൽ ടു എന്തായിരിക്കും? ക്യാൻ യു റൈറ്റ് ഇറ്റ് ഡൗൺ? That is amplitude change of carrier wave divided by amplitude of unmodulated carrier wave. ആംപ്ലിറ്റ്യൂഡിന്റെ റേഷ്യോ ആയിരിക്കും മോഡുലേഷൻ ഫാക്ടർ. അൺമോഡുലേറ്റഡ് നിന്ന് നമ്മൾ സിഗ്നൽ കൊടുത്ത് മോഡുലേറ്റ് ചെയ്യുന്നതിന് മുമ്പുള്ള കരിയർ വേവിന്റെ ആംപ്ലിറ്റ്യൂഡാണ്. ന്യൂമറേറ്ററിൽ കാണുന്ന ഇറ്റ് ഇസ് ദി ഹൗ മച്ച് ചേഞ്ച് ഹാസ് ഹാപ്പൻഡ്. ദാറ്റ് ഈസ് എത്രയാണ് അതിൽ ചേഞ്ച് സംഭവിച്ചിരിക്കുന്നത്, അതാണ് ഇവിടെ കൊടുത്തിരിക്കുന്നത്. സോ ദിസ് ഗിവ്സ് എ റേഷ്യോ, ദാറ്റ് ഈസ് ദി മോഡുലേഷൻ ഫാക്ടർ. Now let us find out the modulation factor. I'll give you some examples so that this will be more clear. First, let us take a signal, a carrier wave. The amplitude of this carrier wave, let us say A is the amplitude, this is the amplitude of this carrier wave, plus no signal, zero signal. What you get will be the same amplitude. The amplitude of the carrier wave has not changed. Here again the amplitude This is A. Carrier wave signal onnuilla. The carrier wave in a so is there any change in the amplitude of the carrier wave? No. Change in whatever was earlier the amplitude, the same amplitude is coming in. So the change in amplitude is A minus A. And what is the amplitude of the original carrier wave? That is A itself. So our modulation factor M is equal to change in amplitude divided by the amplitude of the original carrier wave. So what will this be equal to? A minus A is 0. So this is equal to 0. So the modulation factor is 0% modulation. Okay. Now let us take the case of a signal which has got the same amplitude as our carrier wave. This is the carrier wave of amplitude A plus a signal which is of a lower frequency, but amplitude, I'm going to keep the amplitude same. Same amplitude. This is also A. So the modulated wave, in this case, can you write on what is M? Can you write on what is M? What will happen to, what is the shape of the modulated wave? Its amplitude increases. This amplitude, it becomes 2A. This becomes 2A. So the amplitude of the modulated carrier wave becomes 2A. So the modulation factor will become 2A minus A by A. That is equal to A by A, which is equal to 1, which is equal to 100%. So modulation factor M in this case is 1. That means 100% modulation. Now let us try another example. This is our carrier wave. Again of amplitude A. Now let us take a signal which is having amplitude 0.5A. Amplitude is 0.5A. Our wave will be of this form. And this maximum amplitude will be 1.5A. So our modulation index will be, what will be modulation index? 1.5A minus A divided by A. So this is 0.5. So the modulation index is 0.5 and it is 50% modulation. So here we have taken a signal which is having amplitude less than the carrier wave. Now let us take the case in which the amplitude of the signal is greater than that of the carrier wave. Again, carrier wave has got amplitude A. Plus our signal which is having an amplitude say 1.5. A. Can you draw what will be the modulated wave? Now calculate and tell me what is the modulation factor. M equal to 2.5 A minus A divided by A. So this comes to how much? 1.5. So 150% is the modulation. So now you look at this. In this case, here the signal is having an amplitude much less than that of the carrier. So what happens? The signal that is being carried through this carrier wave has got very low strength. The signal strength will be very low when the amplitude of the signal is small. Whereas you look at this factor here it is 1.5 times, but some part of the signal is lost. Is it not? Just go through the figures once more. So if the modulation factor is greater, some part of the signal will be lost. And if the modulation factor is very less, the signal strength will be less. So that will affect our signal transmission, reception and effective communication. So we should have an optimum value for the modulation factor. മോഡുലേഷൻ ഫാക്ടർ തീരെ കുറഞ്ഞിരുന്നാൽ നമ്മുടെ സിഗ്നൽ സ്ട്രെങ്ത് കുറയും, വളരെയധികം വന്നാൽ നമ്മുടെ സിഗ്നൽ കുറച്ച് ലോസ് ആയിപ്പോകും ഇൻ ബിറ്റ്വീൻ. സോ വി ഹാവ് ടു പ്രോപ്പർലി അപ്ലൈ ദി മോഡുലേഷൻ ഫാക്ടർ. So modulation factor, right now we discussed that it is the ratio between the change in amplitude of carrier frequency divided by the amplitude of the carrier frequency. So that changes depending upon the how much signal strength you are applying. This is a modulated signal I have drawn. This is Vmax. This is V minimum. ES is signal strength or electric field or voltage contained in the signal. EC is that of the carrier wave. Now ES is modulation factor times EC. So this we can write as equal to MEC. Okay. And this is V minimum, this is V maximum, and this was the position of the carrier wave initially. It has got modulated according to a signal. So from this we can write EC is equal to V max plus V minimum divided by 2, and ES is equal to V max minus V minimum by 2. V max minus V minimum, it will be this quantity, that divided by 2, that is your ES. And EC is V max plus V minimum divided by 2, so you will get the position here. Now I want you to rearrange this and get the expression. We can make the substitution for ES and EC here. You substitute for ES as V max minus V minimum by 2. Here M into EC, you substitute this. Substitute, rearrange and get the expression for it. So what will you get? Okay. Let me substitute for ES. ES is V max minus V minimum by 2 is equal to M into V max plus V minimum by 2. So I can get M is equal to V max minus V minimum divided by V max plus V minimum. Get here. So next we are going to discuss about the analysis of the amplitude modulated wave. Analysis of amplitude modulated wave. So we can write down the carrier wave as EC is equal to EC cos omega c into t, where EC is the instantaneous voltage of the carrier wave, and EC is the amplitude of the carrier wave. Now the signal we can represent as ES, which is equal to MEC, where M is the modulation factor. So MEC cos omega s t. Now the amplitude of the carrier wave is getting modified according to the signal. So this is the carrier wave and this is the signal. The instantaneous voltages of the carrier wave and that of the signal. Now once it is getting modulated, for the modulated wave, we can write the instantaneous voltage E as equal to this amplitude is getting modulated according to the signal. So this will become, instead of EC, we'll have to write, can you tell me what we'll be writing instead of EC, because it is amplitude that we are modulating. We have to add this variation to the amplitude of the carrier wave. You have seen in the figure how the amplitude of the, to this amplitude we are adding the signal term. So instead of EC we'll be writing EC plus MEC cos omega ST, because this whole term is being added to the amplitude of the carrier wave into this term cos omega CT. So what will this become equal to? This is equal to EC cos omega CT plus MEC cos omega ST cos omega CT. Now this term, this is of the form cos A cos B. You can write in terms of 2 cos A cos B is cos A plus B by 2. Sorry, cos A plus B plus cos A minus B. So in that term you can convert this. You see that identity. So we can write it as, I'll write it here. So our instantaneous voltage of the modulated wave E will be equal to EC cos omega CT plus MEC. I'm going to divide and multiply by 2 so that I can get in the form 2 cos A cos B. So this will be MEC by 2 into cos omega C plus omega S into T plus cos omega C minus omega S into T. This again you can split up. We'll get 3 frequency components plus MEC by 2. So here we are getting, you can look at the 3 terms here. This is 3 sinusoidal waves. This is corresponding, you can express it as similar to 3 different waves superimposing. So you can have the first component as EC cos omega CT, that is with the frequency omega C. The second component is having a frequency omega C plus omega S, and the third component is having a frequency omega C minus omega S. So you can understand that it is similar to 3 different waves combining together, and this resultant you are getting, which is seen in the figure. So here you can see that it has got, the first component has the amplitude same as that of the carrier wave. Then the second component has the amplitude MEC by 2. MEC is actually the amplitude of your signal. So this is having half the amplitude of the signal. This is also having half the amplitude of the signal. Now we can represent this in the frequency domain. That is, I'm going to represent frequency versus voltage. Omega C is equal to 2 pi Fc, where Fc is the carrier frequency. Omega S is equal to 2 pi Fs, the signal frequency. So omega C, this is omega C of frequency Fc. Its amplitude is EC. This is EC. So this is the frequency component. Then corresponding to omega c plus omega s. The frequency will be fc plus fs. So that will be here fc plus fs. And what is the amplitude of that component? MEC by 2. That is less than EC. Somewhere here I can write MEC by 2. So this is the amplitude corresponding to fc plus fs. Similarly, omega c minus omega s has got frequency fc minus fs. That will be here fc minus fs. It has also got the same amplitude MEC by 2. So this is the frequency component here. Now, this frequency fc plus fs corresponds to the upper sideband. Upper sideband, and the component fc minus fs corresponds to lower sideband. And the frequency bandwidth is from fc minus fs to fc plus fs. Can you tell me how much is the bandwidth? Bandwidth is actually this range of frequency. That means fc plus fs minus fc minus fs. So let us write it down and see what is the bandwidth. So the bandwidth of this amplitude modulated wave is equal to this frequency minus this frequency. That is fc plus fs minus fc minus fs. That is equal to fc plus fs minus fc plus fs. This is equal to 2fs. So this is the 2fs, that is the bandwidth of the amplitude modulated wave. In the next class, we will be discussing frequency modulated wave, and also we will be working on some problems on this amplitude modulated wave. So let us summarize what we have been discussing today. Can you tell me what they are? We have started with amplitude modulation. Yes, first we have taken the signal which is of a low frequency, carrier which is of a high frequency. We have modulated or changed the parameters. What is the parameter we have changed? It is the amplitude. We have incorporated the variation in the amplitude of the carrier wave corresponding to that of the signal. And we have also considered the extent to which modulation is done. That is called modulation factor. Modulation factor is the ratio of the difference in frequency divided by the difference in amplitude of the carrier wave divided by the amplitude of the carrier wave. So if the modulation factor is less, the signal strength will be low. If the modulation factor is high, very high, some of the signal will be lost. So we have to optimize the amount of modulation. Then we have discussed the analysis part, in which we have seen that it contains 3 different frequency components. There is an upper sideband and a lower sideband frequency. And the bandwidth you have got it as 2fs. So this is what we have been discussing today. In the next class, we will work out problems on this, as well as we will continue with frequency modulation.